Hello all! Here's the first test that we're going to perform on the Zener Diode. And in the following video, I'll show you how to hook all this up. It's very simple. Look here. We have a power supply, a plus VCC. This is positive right here. And here's our ground down here. We have a power supply across our 1K ohm resistor and 10 volt Zener. Between the 1 kilo ohm resistor and the 10 volt Zener, we place our voltmeter, and our voltmeter is referenced back to ground. So here's our red lead between the 1 kilo ohm resistor and the 10 volt Zener, and here's our black lead going back to ground. Now, if we don't know what the Zener voltage is, we gradually increase this voltage here from the power supply, the benchtop power supply. We increase that voltage until we reach the Zener voltage. So, for instance, here we have a 10 volt Zener. We start out at 0 volts with our power supply. Increase the voltage, increase the voltage, increase the voltage, and at some point we will see with our voltmeter that the voltage will stop increasing, and that is the Zener voltage of that device right there. Here's the second test we're going to perform. The current through this circuit. Now, I'm going to show you how to calculate the current through this circuit, but we're also going to measure it with our fluke in ammeter mode. That's this device right here. To calculate the current through the circuit, the best way to do that is with this resistor right here. Now we know if we can measure the voltage across that resistor, and if we can measure the actual resistance of this resistor, through Ohm's law, we can calculate the current through that resistor. Now this resistor right here is in series with the Zener Diode. So the current through the resistor is going to be the same as the current through the Zener Diode, and when we have our ammeter in here, the current through the ammeter. From our circuit, I measured 10.04 volts DC across that 1 kilo ohm resistor. Then I isolated that resistor by itself and measured a real 993 ohms. Through Ohm's law, we know that the current is equal to the voltage divided by the resistance. And here we calculated a current through this series circuit of 10.11 milliamps, 10.11 milliamps. Isn't that amazing? Isn't that amazing? So for a series circuit, the current through the resistor is the same as the current through the Zener Diode, and is the same current through our ammeter. Don't forget, when we put that ammeter in circuit, it becomes part of that series circuit. There you go. Look at that. Okay, let's watch the video. Good morning, everyone. We're going to test this 10 volt Zener diode right here. This is part number 1N4740A. There you see There's a black band right there. That's the cathode side, and the other side is the anode. I'm going to show you an easy way to test these Zener diodes, and this will work for any Zener diode. We'll place our Zener diode onto this breadboard right here. Now you don't need a breadboard. You can clip all these together with wires. I have a 1 kilo ohm 1/4 watt resistor right here, and we'll place that on the same row as the cathode. Now we're going to apply a positive voltage to this 1 kilo ohm resistor, and we're going to apply ground to the anode side of the Zener diode. Zeners are placed in the circuit reverse biased. Now, if you had a higher voltage Zener, you might have to up that resistor right there. But for this 10 volt Zener, a 1 kilo ohm resistor will be fine. Let me get my clip leads out here. We're going to attach that circuit to a power supply. Alright, here's our black lead, ground of the power supply. Here's the red lead, goes to the resistor. We're going to take our meter leads right here, put your meter into volt mode, turn this light on, and we're going to clip the black lead of your meter to ground on the anode side of the Zener diode, and we're going to clip the red lead of your meter in between the resistor and the cathode of the Zener diode. That's the point we want to be looking at with your meter. Now, here's the magic. I'm going to turn the power supply on, and I'm going to increase the voltage, and watch your meter at what point it stops increasing. Here we have 1.8 volts at this point right here. Now there's 5 volts on the power supply at this point right here. We have 5 volts at the cathode of the Zener diode. Here we're increasing the power supply. There's 10 volts on the power supply's meter, and we have 9.77 volts on the cathode to ground across the Zener diode. Now I'm going to increase the voltage here on the power supply. We're at 15 volts on the power supply, and notice that we're Zenering at 9.82 volts DC. Let's go up to 20 volts. There's 20 volts on the power supply, and we still have 9.87 volts across the Zener diode. That is how you can test a Zener diode. Now let's take a look at a couple of other things. What is the Zener current at this point? Let me get a piece of paper so we can write all this down. Okay. What exactly is our voltage coming in? Let me remove this right here. And we'll go to the VCC side Okay, we got 19.68 volts right there. Let me go up to 20. Let me get it as close to 20 as I can possibly get it. There we go. We have 20 volts from the power supply. So let's write that down. VCC is plus 20 volts DC. Okay, now I want to know what the voltage across this resistor is. Oh, we just went down. Let's get precise here. We got 19.98. Okay. Okay. Let's see what our voltage across that resistor is. Okay, this is VR is equal to 10.04. Turn the circuit off, turn the power supply off. We're going to measure the resistance across that 1 kilo ohm resistor. Let me get this out of here so it don't come into play. Let me unclip the power supply there. Okay, our 1 kilo ohm resistor is 993 ohms. Now, this is a series circuit. Let's hook all this back up. So, if the current through the resistor is a certain value, it's going to be the same current through the Zener Diode, because this is a series circuit right here. Set all that back up to what it was before. Let's get our calculator out. And through Ohm's law, we know that the current is equal to the voltage divided by the resistance. And our voltage was 10.04 volts. Our resistance was 993 ohms. That gives us a current of 10.11 milliamps. Let's write that down. Current R, which is equal to current Z, current Zener, because it's a series circuit, is equal to 10.11 milliamps. Now, let's put our meter into current mode and we'll measure the actual current. It's going to be milliamps, so we'll put our red lead into the milliamp position on the meter. Get these clip leads out of the way so we don't get mixed up here. We set our meter to milliamp. And this will go here. This will clip onto the ground side. Now what's happening is we put our meter in series with the circuit. So here's our positive power supply lead right here. It goes through the 1K the Zener, then into the current input of the oscilloscope, out common, and back to the power supply. Let's turn our circuit on. Look at that. Our calculated current was 10.11 milliamps. The real current is 10.16 milliamps. Isn't that amazing? How the Ohm's law comes out like that. So the calculated current and the real world current are extremely close together. Now, we've got some resistances added in here with the clip leads, and that might be why this is a little bit higher than the calculated. There you go. I hope you enjoyed that video. That's how you test a Zener diode. Isn't that amazing? Alright. Okay. Here's our calculations right here. If I can get that in the camera. Our VCC was 19.98 volts DC. The voltage across the 1 kilo ohm resistor was 10.04 volts DC. The resistance of the 1 kilo ohm resistor was 993 ohms. Current through the resistor is equal to current through the Zener, which is equal to 10.11 milliamps. Through Ohm's law, the current is equal to the voltage divided by the resistance. There we go. Isn't that amazing? Hey, look at that. It come down to 10.11 milliamps. Let me get that up here so you can see that. There we go. So the calculated and the real world currents are very close together. Okay, we'll see you next time.